Hi students, we're looking at Spiral Review 9. Alright, we're looking at graphing some trig stuff. I've got a cosine function here, so I'm just going to remind myself that this looks like this is a shape. We're going to be showing 2 periods this time, so we'll do 2 full cycles. And let's begin by identifying things that we know. I see my constant being added here, so my midline is going to be 2. Alright, 1, 2. And there we go. I also noticed that my amplitude is going to be a half, so I'm going to make those spaces a little bit farther apart so I have more room. So here would be 1, 2, 3. And then if I do halves, we're looking at like there and there. Alright, let's sketch out my midline just so we have something to work from. I'm going to sketch out my amplitude lines just so we know where our graph is going to exist. All right, next let's find some starting points and ending points for us. So we're going to use our equation here, and this is what's going to help us find the starting point. We've got theta over 3, and if you'd prefer to just use x, that is okay with me, because theta is just a variable. So we got 7 pi over 4 is equal to 0. That's going to be finding the starting point. In solving this, I've got a minus 7 pi over 4 to both sides, and we end up with 7 pi over 4, but the negative version. Multiplying both sides by 3, we get theta is equal to negative 21 pi over 4. So I'm going to put that point somewhere on the negative side of my graph, and let's just call that negative 21 pi over 4. Finding the end of that first cycle, we're looking at theta over 3 plus 7 pi over 4 is equal to 2 pi. Minusing 7 pi over 4 to the other side, we get theta over 3 is equal to pi over 4. And that theta is equal to 3 pi over 4. All right, I'm going to put that's my end point there. Maybe somewhere like there for 3 pi over 4. All right. Finding the middle point there, so exactly in between those two. We've got negative 21 and positive 3, which gives me negative 18. At negative 9 pi over 4, we have our middle number. That's going to be right in the bottom there for cosine. And then cutting each of those in half for negative 21, negative 9, that's negative 30. That gives me negative 15 pi over 4. And looking at negative 9 and positive 3 is negative 6. That gives me negative 3 pi over 4. And there's my first cycle. Now I could repeat these points to get a second cycle. I could even just do the same method again, and this time solve for 4 pi for my other endpoint, and cut in half again. And that would give me those same values that we need to get those other points.
Go over here. Make sure on that previous one, you note the period, so subtract those beginning and end. So 24 pi over 4. You note the midline, 2. You note the phase shift, which was left, 21 pi over 4. And you note the amplitude, which is 1/2. All right, speaking of all that stuff, let's do that here. So we have a low of negative 5. We have a high of 1. In between negative 5 and 1 is negative 2. So that means we have a middle of negative 2. So I'm going to have a y equals, the negative 2 is going to go out here. From negative 2 to 1, negative 2 to 5, that's 3. So a 3 is going to go here. You can pick sine or cosine. It doesn't matter. Maybe I'll pick cosine. And maybe that's where I start. So it's going to be negative 3 cosine. It's going to be negative because we're starting instead of up top, we're starting down the bottom. So instead of starting at max, we start at a min. And this right here is 3 pi over 2. And we end here which that's 10 pi, 11 pi over 2. So that means the period is 8 pi over 2, so 4 pi. So 2 pi over 4 pi, which I could write as 1/2. And then the shift is right 3 pi over 2. So I regret this -2 here, it's in the way. So right 3 pi over 2, so minus 3 pi over 2, minus 2. And we did it. Trig Model. Use the information provided to develop a model. Waves standing in wavy water. Notices the depth of the waves varies in a periodic way that can be modeled by a trig function. You start the stopwatch to time the waves after 1.1 seconds, and then again every 3 seconds, so that's the period. The water just touches his knees, so that's a max. And then the water recedes to his ankles, that's a min. Waves' ankles are 12 centimeters off the ocean floor, his knees are 55 centimeters. So in between 12 and 55, so that's 67, divided by 2, 33.5. So that's going to be 33.5. That's going to be the middle. And then 55 to 33.5, that's going to be 21.5. That's the amplitude. After 1.1 seconds, the water just touches his knee. So that's a max. So I'm going to pick cosine. And it says we start the cosine at, this is plus, 1.1, so x minus 1.1, because shift me to the right. And then every 3 seconds, so 2 pi over 3. And that should work. Use stop model to estimate the depth of water, 11 seconds. So plug in 11. So 21.5 cosine 2 pi over 3, 11 minus 1.1, plus 33.5. Make sure I am in radians. And I get 26.856, and the depth is in centimeters. So somewhere around there. Sounds good. Obviously, on your quiz, show me the model, maybe explain why you're doing that, and then explain what you're doing here. So write that model down again, or tell me you're plugging in 11 for x, however you want to think about it. Make sure you plug that in. As I keep saying, you don't have to use a cosine curve here. You could use a sine curve. You could use a variety of different things. You would have to kind of think about things. If you can't tell from the verbal description here exactly what's going on, draw yourself a picture. So your picture in this case would be, you have 1.1, and you have your max, and then 3 seconds later, so 4.1, you also have a max, halfway in between, halfway in between, halfway in between. So now you have what your model looks like. And now you can maybe better conceptualize what's going on. If you need to do that, do it. It is a good strategy. Curve is z of x. Sketch a graph of negative zx plus 2 plus 1. All right. So this is going to move me left 2. It's going to flip or reflect horizontally. And then up 1. So we're going to let's take care of the y stuff first, because we can move left 2. That's easy. So if I'm looking at the point 5, 3, the first thing I do is I multiply by -1. So -3, and then I add 1. So I'm at -2, and then left. So 5, 3 wound up there. If I'm looking at the point 0, 2, 0, multiply by -1, and then add 1. Oops, I forgot to move left, and then left 2. That makes more sense. There we go. I was a little confused. You noticed my hesitation there. I was thinking the slope changed, but it should not have. Now let's look at the point 0, 2. Multiply by -1, so -2, and then add 1, so -1, and move left. And then maybe I'll do, I don't know, that looks funky. So we've got this curve that does this sort of thing. Maybe I'll do this point right here, -1, 3. So multiply by -1, -3, add 1, -2, and go left 2. And we have a curve like that. So we'll have some sort of curve like this. And then let's do this one, -3, 6. So 6 times -1 is -6, plus 1 is -5, and left 2. And we'll kind of, I don't know, curve something like this. If it's not beautiful in terms of the curves, I'm not too worried about it. The important thing is the points. Make sure you have some points in there. All right, domain. The domain for z of x. So z of x, the domain is from -3 to 5. The range is from 0 to 6. The x-intercepts 2, 0. The y-intercept 0, 2. Increasing. It is only increasing from 3 to 5. Decreasing. It is decreasing from -3 to 2. Positive. -3 to 5. Negative. It isn't. So maybe it does not exist. Max. The max is -3, 6. And the minimum is 2, 0. All right, beautiful. And right, ooh, that was fun. Okay. Sketch a graph of the parent function. So the parent function, I'm going to do in green. The parent function in this case is x squared. So x squared goes through 0, 0, 1, 1, 2, 4. That's x squared. All right. So for the transformed function, we take 0, 0, we multiply by 0.5, and we subtract 3, and then we go right 2. Because it's going right 2, multiply by 0.5, move down 3. And then for 1, 1, multiply by 0.5, subtract 3, so that's 1/2 minus 3 is -2.5. And then move right 2, 1, 2. Same idea for the other one. And then 2, 4, multiply by 0.5, 2, subtract 3, -1, move right 2. And then, since we're symmetric, we can play that game. For number 6, determine the domain. The domain, really of both of them, is all real numbers. For the range, for my new function, my transform function, it is from -3 to infinity. So bracket on that, parentheses there. For my parent functions, it's from 0 to infinity. And what do we got here? Sketch a graph of the parent function. So the parent function, I'll do in green again, is 1 over x. So 1 over x, let's see, if x is 1, goes through there, and then it's going to kind of swoop like this. If x is -1, goes through there, and it's going to kind of swoop like this. I could be more specific, I guess. I guess I could have plugged in. Maybe I should. I'll be more specific for you. I got you. So if I plug in 2, that's 1/2. So that's right here. If I plug in 1/2, I get 2. So there's a little more specificity for you. And then similarly, I have -1, -1, -1/2, -2, -2, 1/2. Now let's graph this. This is telling me to move right 3. So I'm going to have a vertical asymptote at 3. So I'm just going to draw that in. And I'm going to move up 1, so I'm going to have a horizontal asymptote at 1. So, to figure out where the point 1, 1 goes, let's go ahead and multiply it by 2. So that's going up to y equals 2, and then adding 1, so 3. And then we got to move right 1, 2, 3. And then 2, 1/2. Take 1/2, multiply by 2, so that'll be 1. Plus 1 is 2. And then right 3. So a y value of 2, x value of 5. For 1/2, 2. Multiply by 2 is 4, plus 1 is 5. And then 3.5. So 3.5. So something like that. Similarly, -1 times 2 is -2. Add 1 is -3. And move right. 1, 2, 3. And then -2 times 2 is -4. Add 1 is -3. Then move right. 1, 2, 3. And then -1/2 times 2 is -1 plus 1 is 0. 1, 2, 3. So the domain is real numbers except for x cannot be 3. The range is real numbers except for y cannot be 1. So asymptote is y equals 1. Vertical asymptote is x equals 3. And we are done.